Welcome and thank you for coming to B-Sides Las Vegas, ground floor. This talk is called Hardening Containers with Seccomp, and it's being given by Ben Hirschberg. I have a few announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, Adobe, Aikido, and our gold sponsors, Profit and Run Zone. It's their support along with other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, please use the audience mic so that YouTube can hear you. Make sure to point at the mic. Sorry, I'm reading what it told me to do. You may be asked to make announcements. Oops, sorry. As a reminder, B-Sides Las Vegas photo policy prohibits taking pictures without the explicit permission of everyone in the frame. These talks are all being recorded and will be available on YouTube in the future. Thank you so much. And without further ado.
Good morning. Sorry. Good morning, everyone. Thank you for coming to this talk. I will try to be easy on you this morning. You know, it's early morning for first talk. I see that most of you still have your coffees on, which is great. Hope that this will work smoothly. I'm going to give you 2 live demos. Let's hope that the demos will work. If not, then we'll switch back to recordings. So those of you who don't know me, my name is Ben. I'm a co-founder and CTO at a cloud security company called Armo. Used to be worked at different places before. I'm working in the security industry for more time than I want to admit, but coming from a white hat background and going into more to product and development part of the industry. We are going to talk today about an open source project I'm a maintainer at. It's called Kubescape. It's part of the Cloud Native Computing Foundation, which I'm an active member of. Yeah. Let's go in. So among you, first of all, who heard before this talk about Seccomp? Who's using actively Seccomp in their products? Okay, great. So actually, this is really the talk is about. So the talk is about what is Seccomp and why it is not really widely adopted and used, and how this can be, how we can turn Seccomp into something that is more usable at least in the container and cloud security sphere. So I'm going to talk today about what is Seccomp, giving an intro for those who are not, who don't know what it is, and then we'll go over how it can be used for prevention in containerized environments, and then I'm going to show you a way to be able to make it much more usable using application observability and understanding how applications are behaving, and then applying the right profiles for the given application. And I'm going to do a demo. I've come with a real exploit in a real application to showcase you how it works. So Seccomp is actually a rather, I would say, old feature in Linux kernel. It's, I think, I haven't checked it precisely, but it's been around something for nearly 20 years in the Linux kernel, if I'm not wrong. But even if it's less than, not far less, it was born in order to be able to build sandboxes, process sandboxes that are running on Linux kernel, and it was built for 2 purposes. originally. One was to build sandboxes around things like browsers that are, running less trustable code and were prone to different exploitations before, and therefore there was a need to create a sandbox around these applications to limit them. So even if there is a real exploit on them, then the attacker won't be able to proceed to the next step. The second reason later become is to limit also system calls that may be problematic for the kernel, in the sense that if there is a system call that has a known exploit in a given version, still the defense can use Seccomp to limit costly system calls if the application doesn't need them. So the original history was that, again, 20 years ago, to create processes that are limited only to 4 system calls. The way it worked is that a process that when it started up could call into different system calls and just limit itself from any further system calls, like going down in the privilege scale. These 4 system calls were read, write, and exit and close. So in general, the idea was that I can create a sandbox process, which is just like, doing some basic I/O, maybe closing some file descriptors, and then it exits. Again, think about the use case of browsers and executing JavaScript in the browsers. Then after it come a more complex version that was using BPF, which later become eBPF, to define much more fine-grained rules around what is allowed and what is not allowed for the process to do, and creating very complex scenarios, even like just not simple firewalling scenarios, but checking into the arguments and so on. So Seccomp became much more powerful in the early 2010s. And then when the containerized environments started to come up, Docker came up. The guys at Docker came up with a great idea to create a basic profile, which we are going to talk about today, that limits the system calls of a containerized process that it can do, and generally protect up, not just the application, but in general the host machine that runs the container from attacks. And as containerization evolved, Kubernetes itself, which is the de facto orchestration tool today for containerized environment, also started to support 5 years ago fine-grained Seccomp profiles. So what's the present state? So the present state in general is that there are pinpoint usages of Seccomp, again, browsers, very specific applications where Seccomp is used. I've seen very interesting usages as well for Seccomp also into intercept system calls, and I've seen great interesting things, but in general, the security industry or parts of the security industry know Seccomp for Linux hardening, and it's great. But in general, in the main, in the most places where our Linux today is used, and Linux is used for very broadly, obviously, in the cloud. It is much less used. It is very, very rarely I see companies are taking advantage of Seccomp to protect their environment. And this is the thing we are trying to change and to make Seccomp more usable. So why it is interesting? Why Seccomp is interesting in cloud environments? So Seccomp is interesting in cloud environments because because the main threat model of cloud environments, and especially if we are talking about containerized environments, is twofold. If we're assuming that there can be some malicious code that is running inside a container, the attacker can do two things or advance to two directions. One is to try to create an exploit on the kernel and somehow, leave the confinement of the containers and take over the VM or the Linux host that is running the container. This is one thing, and usually when this is done through some kind of system call that the attacker is able to invoke with specific parameters, and then it enables it to do a container escape because exploiting some kind of a vulnerability that there is in a kernel that wasn't patched, or maybe it's a 0-day and no one knows that there is an issue there. That's one thing. The second thing is that the attacker might try to do some lateral movements, maybe not trying to attack the kernel itself, but still the workloads are rather unlimited in what they can do in their environment. So they can talk over the network, they can invoke different network calls in their environment if there is like no network policies around that are super limiting. Files that are written on the disk and so on, maybe environment variables, so on. So there are like plenty of things to do, lateral movements too. And these two, in this threat model, attacker can either come from exploiting exploiting vulnerability inside the container and coming from the outside world, and it comes from the public internet, or it's just like adding itself into the supply chain and the containerized environment starting a container that already includes the malicious code. And this is our basic threat model. So the way I see it is that one of the ways that Seccomp would be really great for containers is to limit the availability of an attacker to what it can do to the progress attack. Maybe not limiting the actual exploit of the initial attack vector, but to like create these lateral movements or trying to go over to the kernel to continue an actual attack. And I think that this is where Seccomp can be super useful. So let's talk a little bit about how Seccomp works. So Seccomp for containerized environments is working in a very schematic way. As I told you before, in general, Seccomp, if you are programming it through the Linux API, you can like create very specific use cases and implementations of limitations. But if you are higher level abstraction layer like a container runtime, you don't want to allow all the users to all these features because it's just like super complex to do, and it would require deep knowledge of programming. So the way that Docker originally defined Seccomp profiles, and this is like a very big difference to know that in between the Seccomp API of Linux kernel and the Seccomp profile of the container runtime. So the Seccomp profile of a container runtime is defining this very schematic way of like, there is a system call. It has very specific arguments, and like just tell me what should I do if this happens. So if there is a fork system call, then block it. Don't let the application call into fork or clone and prevent it to create new processes. Or if there is close system call on file descriptor 5, then just like block this system call. And this is how the schematic Seccomp profiles for containers are looking like. They have this like list of system calls, but optionally arguments and what to do with them. And this is how they look. So what are the actions? Seccomp today enable you to do different responses in case of different system calls and arguments. So the most basic is just to say allow, let it go through, don't care. If you are going from lowest priority to upper, which is like from the bottom to the top, you can ask Seccomp to log this event, and then it will be written into the kernel logs. I will tell you in a minute why it is super unuseful in a cloud environment, but we'll come back to that. There is this notify option when you can hook into create a hook into Linux kernel and get notifications about a system call event. You can configure the Linux kernel that if there is such a system call, then just return an error code like not allowed, and you know the application continues to run. And it will just get an error on the system call, and that's it. There is this trap signal. You can also define Seccomp to throw a signal on the process. It is for applications that are very aware of how the Seccomp API works in the Linux kernel. I've used it a few times, but it's just like for very niche purposes. And then obviously then you can have the kernel to kill either the caller thread or the whole thread group, the process in this case. So kill the application in general if there is the invocation of the specific system call. So you have all these options. Now I wanted to return to the logging option. So you're thinking that it's like super nice to like define that if there is an application that is like calling to a very specific system call, and I just have a log event about that. Now the problem is that most cloud environments, it is like really hard to create this feedback loop because these logs are not really collected anywhere. There's no standard way to collect it. There's like a very specific implementation for each cloud environment, cloud provider. They are not at the upper layers of container runtime, Kubernetes. It's just like these logs are, you have no unified way to access it, and it's like a shame, but this is what it is. So again, returning to the point that I had before of the difference between the system call API and of Seccomp and the Seccomp profile itself. So the way you're working with Seccomp, in case you're using directly the Linux kernel API, is you have like two. Mostly you have the Seccomp system call itself, which is like has a man page of which is like super long. You have to, including BPF instructions and everything. It's hard, complex. Most people need to invest a lot of time to learn it. On the other hand, in the containerized environment, to implement, it's not really a programmatic implementation, but you're just defining this JSON configurations of like what I told you before, that when this system call happens with these arguments, what to do. That's it. The format is the complexity of these two things are really, really different. But I'm going to return to this because I could really say that it's really hard to learn the Seccomp API. It's like any other kernel feature. You have to really learn how it works to be able to control it. And the JSON file is much more simpler. But having said that, like today it's really hard for people to understand even the JSON file because of other reasons. So we'll come back to this a little bit later. So how this JSON file looks. Sorry for the small font. I hope that you can still see something here. But again, it is like this super thing list of you can see syscalls, items. For every item, there is a string for a list of the system calls and then the action to take. So you have a specific system call, for example, close. You can define the action to take. You can define the argument filtering of I want to apply on this this action only if there is a given argument to it. The argument filtering is like super complex. And because think about the following things, you would say, what kind of argument filtering I would like to implement? Like, obviously, I wouldn't like anyone to open a file called /etc the shadow because I just want to prevent it. Now, how the kernel sees this string? how the kernel sees the string as a pointer, to username, to user space address, and like Seccomp is not good at it. You cannot read directly this, and even maybe with eBPF you could read that, but it's like super complex. Nothing that this JSON file can handle. So it's this argument filtering is just partially useful. So if it's so cool, why is it not used? So the main thing is that, as opposed to, I guess you came to this talk because either, Linux, Linux security, you heard about kernel, you're interested in, and you heard what is a system call is. But it's hard for me to break you the news that most people in the world who are in this industry don't know really what a system call is. And people just don't understand. The developers don't understand this notion. Like, think about it. And I do really trying to say this without without any hint of disrespect. But think about the Java developer. If you ask him, okay, what kind of system calls you're using in your application, like he's going to be like, well, no idea. So it's really, really hard to like create an environment where people are aware of what system calls they need in their application. So think about a containerized application. I ask you today that, for example, you are using a super simple application called Elasticsearch in a containerized environment. Like, what system calls it use? Then the next question is, okay, which version of Elasticsearch? Which version of Java runtime? And you start to think it's becoming super duper complex discussion. And then afterwards, like, okay, I'm as a security person, I'm creating this environment when I'm limiting system calls. And for some reason, it looks like the container is running. It's not crashing. Is the application working? Do we know that the actual application is not broken, like because we are limiting something that that is hidden behind us? So it's really, really hard to understand as a security practitioner, okay, that we are not breaking functionality. And now I'm returning to this notion of like Seccomp has that logging, blocking system calls that are blocked. And the problem is that since we don't have a reliable or unified way to understand that we've blocked something in a containerized environment, it is really hard for us to understand that we broke something. So it's very complex. So now how it's tapping into the ecosystem of the containerized world. So as I told you before, Docker, when it came out, and all the other container runtimes that came after, just inherited this property that when you are running a container, it already attaches a default basic profile of Seccomp. So if you're, and I'm going to show it to you in a demo in a minute. So when you're running a container with Docker, just Docker run or Podman run or whatever, it is there is a Seccomp profile active behind the scenes, which is like, I do think that, whatever you think about Docker, from my perspective as a security person, kudos. Like I really love when a vendor comes out or project comes out and they are just like trying to be really strict on security, and it's even like works to some extent. So it's great. On the other hand, came Kubernetes, which is like I would say my home team. I'm a contributor to Kubernetes and work, and as part of CNCF, it's our project. But I have to tell you that the less good part is that when Kubernetes came out, when you're releasing the first version, you just want to make everything work, right? So what's the first thing you're disabling? Seccomp, security, no security. So Kubernetes disabling Seccomp in the container runtime by default for every workload you're running. So you're not inheriting the good things that Docker came with. And reintroduced in 1.2, Kubernetes reintroduced the support, so you can define the basic Seccomp profile, or you can bring your own. So so you have these three ways to work in Kubernetes. Either you are running in an unconfined environment, which is a no Seccomp. You have the default profile, which is the basic profile of Docker, which is, by the way, a little bit changed over the time, but it's not super interesting, so I don't want to go in there. And you have the local host profile when you are just like bringing your own Seccomp profile into Kubernetes, and you're running a container with a custom Seccomp profile and praying that it works. So let's talk a minute about the basic built-in profile. So actually, it's really cool because it blocks only around 50 system calls. Again, I don't have the specific number because it's changed over time. But it blocks out a lot of system calls that were usually really not used in the containerized application. Think about, mount, pivot root, and stuff like that, which is usually in the normal application, it's not like system calls that are used, but they are like really good things for an attacker to use, right? They are like system calls that are also, they were prone to different attacks. And also it's just like something that the attacker would love to have, especially unshared to exit the containerized environment. So they are working really smoothly. There are a few applications that are not good with those, but in general, most applications, like 99% of the simple applications, are working good. Mostly, I could say the same about databases. There are a few exceptions with that because different file system management related system calls that are like just making problems with few database setups, but in general it's working. And there are like also like very, very specific examples of well-known CVEs in the Linux kernel that are just like not exploitable if you have a Seccomp by an attacker, if you have a Seccomp the basic Seccomp profile in place. Now I'm bringing you this really, really super nice screenshots about custom profiles. These are super cool. Again, no one understands really what's happening here. Like you have just like this list of system calls that are allowed, and that's it. The reason why I wanted to show you this slide, because it's just like I wanted to give you the feeling that it's complex. It's like, to understand what's in here, you have just like a list of system calls, and that's it. And it's hard. So I'm going to show you the simple demo. I just wanted to do a little showcase of how the basic profile in Docker works and what kind of things it prevents. So I'm going to run two nginx containers, one with the basic profile and one is unconfined. I'm going to try to create a child namespace in both of them. And I will try to access the kernel keyring in both, and I'm going to show you that the server is still running. Now, sorry for, let me go over to. Okay. Okay, so let's go over it. So we are starting the two containers. So you can see here that the first container, do you see this right? Or should I? Okay, I will try to, let me try to go over. Its colors, let me, maybe, where's the white? Is it better? This is experience, guys. So we've started one container. This container is running without confinements. I needed to, since this is not the the default setting. You know that I needed to tell Docker to run it unconfined. I'm running the normal container, which just doesn't have this option, and it's running by default. So I'm just installing the key utils, which is like less of, and hoping that the network is working. Wow. Okay. This is the nice part of the live demos, that even you're fucking up with the step that you didn't think that it will go wrong. Let me try to see that the network is going. Let's give it a second and we'll see if it's able to download. Okay, let's switch over. I'm switching over to my phone, restarting. Let's restart. Yeah, eventually we'll come over all these problems. Okay, so what you can see here is that I'm checking that whether there are any Seccomp filters applied, none of them in the unconfined container. I'm trying to create a new Linux namespace. I was able to create it. I'm trying to access, the keyring. I'm able to create it. So on the other part, let's see if Seccomp profile is enabled. You can see that there are like Seccomp filters installed. I'm trying to create a namespace. I'm blocked. I'm trying to access the keyring, unable to do this. Okay, and I'm also showing that actually Nginx is working. So that's the third thing I wanted to show you. So now returning to our discussion. This is, guys, there's going to be more interesting things, guys. So sorry, I even thought of removing this demo. Like I just wanted to show something really short. But in general, so the problem is that with the basic profile, that there are like still a lot of things that can be exploited with the basic profile, and there are not a lot, but there are applications that are not working simply with basic profile. So we are like, it's like a glove one glove that tries to fit all, like it's not working everywhere. So, so the question is like, if I'm trying to go over and build better tailored Seccomp profiles, what can I do? How do I know which system calls are running and which system calls are not? So there are obviously like, tools to understand and list it, ptrace and so on, but these are like very problematic to use in a containerized environment. It's also, if I'm trying to create for a very specific application, for example, I told you Elasticsearch, to create a Seccomp profile that it's tailored to it. It depends on the actual configuration of the application. So again, I'm getting back to the same problem I was before, that I'm trying to create a generic application profile that will allow system calls that shouldn't be there. And the issue that what if I'm blocking something that I should be blocking according to profile, but in general it's used. So I have a problem. So the whole thing was built up to this point to bring you that, okay, there is a future. There is a future here to build upon. And this is one of the things we've tried to solve in the Kubescape open source project. So just a little word, because we don't have time and I want to go to demo. So in Kubescape is a Kubernetes security platform supporting for posture things, for vulnerability scanning, configuration scanning, to supporting generating network and Seccomp profiles that you will see, and runtime detection tools. If you want to get to our website, scan the QR code, and then if not, it's Kubescape.io, so you'll find it. So the way Kubescape is working, Kubescape has this node agent that is running on every Linux node, and it just sees all the containers that are running and sees what system calls they are invoking. So it really learns how the container behaves, and since it's logging the system calls that each container uses, it can like create this list of per container of the system call usage, and we are using eBPF to do that, and what the point is going to be here that when we have these Kubernetes API objects that Kubescape creates that we call application profiles, that are logged per each container, the application behavior. So it logs the processes that are running, the network connections, the file access, and all these like good things that a security engineer would need. It also logs the system calls. So what we are going to do is we are going to use these application profiles objects to turn the list of system calls into Seccomp profiles automatically. What I'm going to show you is I'm going to showcase you the power of this through a CV which I prepared for this demo. It's in the change detection project. That CV is enabled a server-side template injection attack. So actually, I can through a Jinja template, I can inject Python code into the server side, and I can run anything from the client to the server, and I'm getting arbitrary code execution of the container itself. So what I'm going to show you in the second demo, which again, hope it will work, is I'm going to try to inject code that steals the Kubernetes service account token, which is, if those who don't know, every Kubernetes container by default has this service account token mapped into the container, which enables the container to authenticate itself against the Kubernetes API, which is, think about it as just an API key that is located in the Kubernetes container. It's just like a cool thing to steal, because afterwards you can talk to the Kubernetes API using that. So what I'm going to do, I'm going to show you the exploit itself without in an unconfined container. Then we'll generate a profile based on the application behavior, apply that profile, restart the container, and then we'll try to re-exploit it. And if everything works, we are going to block the actual exploitation itself. So let's go over, and fingers crossed. Okay, so it is the things are up and running here in my Kubernetes cluster. So I have pre-installed this change detection application, which is the vulnerable application, and Kubescape is running here in the background, which I will talk about a little bit later. Now let's do an exploit. So the way it works, I'm going to talk with this service through port forward, which is just like a technicality for me to talk to it. So I'm trying to exploit the actual SSTI vulnerability. I need like different, I've taken the publicly available POC and turned it into this demo. So it's not, the credit is not coming to me. I did some just small tweaks. So I'm obtaining the token, CRSF token. Let's hope that the webhook site is working, because I wanted to show you what we are stealing. So as you can see, I've seen two posts. Maybe it's from yesterday. Let me try to see. I'm exploiting now the actual payload, and payload is sent successfully. What you can see in the actual payload here is this Python code hidden inside the Jinja templates. So you can see here that I'm trying to injecting code to open the service account token file and then post it to the webhook site. Let's go back, and you can see that the webhook, the actual service account token was taken from the container through this attack. Okay, that's it. Okay, you've been pawned as usual. Okay, now let's go over to the protection, which is the protect sage. So what I'm doing is I'm retrieving this observability object, which I told you, which is the application profile that contains the system calls. I'm using kubectl get application profile, saving it as a JSON file, then running a small script to convert the list of the profile to an actual application profile CRD that Kubescape knows to handle. I'm deploying it. Now I need to tell the Kubernetes deployment to use this profile, so I'm going to patch it now. And the actual profile is set up. Let's see that the pod is coming up and not crashing. Okay, so it's up after I've added the new Seccomp profile. Now let's try to exploit again the CVE, and now fingers crossed. I'm running the same script, so doing all the technical parts of the exploitation itself. Okay, let's try to see okay, so we don't have any incoming data, and let's hope that it's going to work. Again, the payload itself printing out. And now I'm executing the attack. I've sent the payload and nothing came in here. So actually the exploit didn't work because it caused the exploitation. During the exploitation, and I've used the system call that I need to use a system call that wasn't available in the profile, and the profile blocked it. So the exploitation was stopped during the middle. So, and then just to show you like good side effects that if I'm coming and I would try to open a shell in this container, for some reason I'm allowed to right now, which is surprising. But in general, most of the cases I would be blocked. That's strange because I chose it yesterday. So eventually there was a fluke in the demo, but in general, that's the idea. So let's go over to the next slide. So just like a few alternatives to Seccomp profiles, I'm not saying that Seccomp profiles are a good thing in the world, like the best eventual solution that you have, but they are there. They are in the ecosystem of the containers. So trying to introduce any kind of other solutions. And by the way, I love the Landlock LSM. Anyone who wants to read something interesting, it's a really cool project. All the others are really hard to implement in a containerized environment. AppArmor and SC Linux are there, but they are like really hard to move. Like, they have the same problem as Seccomp, that you can only work with predefined profiles, and it's super hard, and it's either too permissive or killing your application. So it's not an easy world. But in general, Seccomp can be a really great way to protect and harden containerized environment. And there are tooling here, and anyone who wants to contribute to the open source project and play around with it, you're welcome to join our the Kubescape Slack. Come to our website and you can see where you can join the community meetings and the Slack channel. And in general, we are really trying to like gap the usability problem around Seccomp profiles and make it usable, because it's really important to harden these environments. That's it. Thank you very much. And if there are any questions, I will be happy to take. I don't know, how is the questioning working through the phone?
Hello, thank you for your presentation. So I have a question. How can I justify to my CISO that I'm going to have to spend several hours with developers securing my containers when there's also a possibility that some of the CVEs, as you mentioned, they are not even covered by Seccomp? Is it worth it? How can I justify that? And the level of complexity that it comes with it, with that.
So it's a great question, and thank you for asking that. So the way I can explain to CISOs, and I'm on the vendor side here most of the time when I'm talking to CISOs. So one of the major problems that CISOs have today is that the overwhelming number of CVs they need to somehow manage, and by saying that Seccomp is like a way to prolong the time that you need to invest into updating the actual applications. When there is a CV out, then you have 30 days of like patching that CV. But if you have a Seccomp profile, and by the way, I think that most compliance frameworks are also supporting this claim that you can prolong this 30 days to even 90 days if you have these additional protections in place. So the way I think to convince a CISO in this case is really to say that, look, one of the biggest things that hurting you is the overwhelming number of vulnerabilities that you need to patch, and you need to have so this is a way to give you much more time and limit the number of CVs you need to patch eventually in the environment. Again, this is not hard science, okay? Because not it's hard to tell which CVs can be exploited and which can't given a given Seccomp profile. But as a rule of thumb, and many of these compliance frameworks that CISOs are dealing with are working with a lot of like these high-level decisions, which are rule of thumb. You can save time for yourself in the patching and the number of patching you need to involve.
When you're profiling all the Seccomp profiles dynamically and like in the cluster, how do you prevent accidentally capturing something like a clone operation or somebody like the danger system calls you wouldn't want, but like your container is accidentally making those system calls? How do you make it more secure than the default one?
I'm not really sure that I understand what do you mean by accidentally, and I tell you what. Usually when I get this question, I get in this forum, please confirm if I'm right, but usually I'm getting this question in a way that people are asking, what if I'm capturing during the profiling a real attack? There's a real attack and I'm just like capturing, I don't know if you saw that I was able to open the shell on the container, which was like totally strange because maybe when I profiled this container, I opened the shell and it was just captured and therefore it went into the profile automatically. So yeah. It's something that either you are generating these profiles in the CI/CD processes, like in staging environment and capturing and then rolling out to the production with the profile. And in theory, you will have if you're doing it through GitOps, then you will have a clear paper trail of what was added and what was changed during the time. But I will be happy to discuss it further if we'll have time afterwards. That's it. Yeah. Thank you very much, guys.